So today we will discuss this problem of which is known as separate black and white balls. So basically, we are given an string, this one, and one basically represents a black ball and zero represents a white ball. Now we need to run an algorithm so we can basically separate the black balls and white balls. And as per the equation, the white balls should come first, and after that black ball. So the result of so basically what the operation is demanding, like we need to do something so that all the white balls comes at the front, and after that we have all the white balls. So there are one, two, three, four, five white five black balls. This shall be, so this is the required operation, but we just need to tell what's the minimum number of swapping we can do, and we can only swipe or we can only swap to the adjacent elements. Like this can be swapped. Likewise, we can do by doing this type of swapping, we just need to arrive at this position. So how many minimum swaps we require? That's the question actually. Now let's discuss the solution. So, so this is a basic question of two pointers basically. We will find out the total number of zeros. So here total number of zeros is 3, and this is a greedy algorithm. So what we can say is basically so if you consider this 0, right? And so what was the output? The output was 3 zeros and 5 ones. So if you think of this 0, so what shall be the nearest 0 location available? You can shift either to this location or you can shift to this location, because both of them requires at least exactly one swap, which is the minimum we know. But again, think of this 0. How many swaps? So suppose we swap this 0 to this location, right? So what the string, so what shall be the string now? So if we swap that 0, so this 0 to this location, our string becomes 1 1 0 0 1 0 1 1. Now again, this two position again needs to be filled by zeros, right? So let's so we can so we need to put these two zeros over here, which will be computationally expensive, as we require for this zero we require one two swaps, and for this zero we require one two three four swaps, right? So this is not the best approach. So what we can do is basically, or what we need to do is basically, uh, we know like this location or the first three locations will always be filled by 0. So we need to find the nearest 0 which can be shifted to the first desired location, right? So we have so this location, so this 0 should be shifted to here. So let me just clear things out for clarity. So we had this one 1 0 1 0 1 0 1, right? Now for sake of simplicity, so basically this 0 needs to be shifted here, and this 0 needs to be shifted here, and this 0 needs to be shifted here. Because if we see, so this is the minimum number of so this, if we do this, this will lead us to the minimum number of operations or minimum number of swaps that we can do, because we are only allowed to swap only to adjacent elements, right? So what we will do is basically we will keep a pointer uh, at this location first, and try to find the nearest 0. So our nearest 0 is this one. We basically we basically swap these two elements and move to the next position where we need to have 0, right? So this position, what is the nearest 0? not this one, not this one. We'll again swap to here and we will just find the difference in position. Like so this is at first index and this is at 0 1 2 3. This is at third index. So difference of this is 3 minus 1 equals to 2. So we will add 2 to the result. Similarly for this one, so the difference was 1. Like this was at 0 index and this one is 1 index. 1 minus 0 1, which is 1 minus 0 1 minus 0, which is 1. So we need to add 1 to the result. So this way if we do, basically keep a pointer to the location in which we desire 0 to be present, and we traverse from left to right, start trying to find the available 0, and we just need to find the subtraction of these two locations. So this will give us the result. You can find the uh, coding approach of this in my description box. Thank you.